Hi, thanks for clicking the video and welcome to iTech Solutions. In today's video, we will protect our GRE traffic with the IPsec. Okay, as you may already know that the GRE does not provide any encryption or any data confidentiality. So it is must that we protect this traffic with the GRE. Okay. Though it does not provide IPsec, but we still use it in our network environment, and the reason behind is that the it can carry any protocol data. Okay, you can use carry OSPF, okay, EIG, RP traffic or BGP. Okay, any protocol traffic can be carried with this protocol. Okay, so that's why we use the GRE in our production environments. Okay. So first we will capture the traffic on our ISP without the IPsec and after the IPsec. Okay, and we will see what is being sent over this our tunnel. Okay, so let's start the configuration. Okay, so this is my R1 router. Okay, so when I view my interface, okay, the show interface tunnel and the status is tunnel up. Okay, means I can send traffic from my local LAN to the R1 local LAN without with the GRE tunnel interface. Okay, the tunnel status is up, and this is the IP address of the tunnel. Okay, and tunnel source. Okay, from where the traffic is will be originated and the tunnel destination. Okay, these are the interface of R1 1 and R2 interface 1. Okay, so let's first we will capture the traffic. Okay, click on ISP1 capture and we will capture the traffic on 0 interface. Start capture. Actually this is my second capture, and let me discard it first, cancel it. I don't want to update right now, and our data capture is starting, and this is some keep lives going on between R1 and R2 to keep up the GRE tunnel. So let's first I will log into my Linux server. Okay, and I will do a telnet from my Linux server to R2 to manage it. Okay, so for that first we will do ping. Okay, and 10.2.2.1, and this interface is the R2 local LAN interface. Okay, and we are able to get there, means our traffic is going through the um, our tunnel interface. Okay, that's why we are able to get there. Now to manage it, I will use telnet and the IP address of my R2 local LAN interface, router interface, and press enter. Now here it asks me for my username and my password, and I am logged in to the my R2 router. Okay, though I am logged in, but still I cannot get to the privilege mode because I did not set and enable mode password on R2. Let's set it. Okay, enable secret, and I will do Cisco. Yes, okay, right. Now go back, save the configuration, and go back to our Linux client, telnet session, press enable and our password, and we are able to get to the router or privilege mode easily. Now show running configuration, and sorry, there is show running configuration, and we are able to view all the configuration of the R2. Okay, now let's open our packet capture, and here this is our telnet session. Okay, let's filter it with the telnet. Press enter. Okay, there is misspelling mistake, typo error. Okay, so if I open it and Okay, click on here. I can see there is R and N. I can see there is more data that is being listing here. Okay, so everything that is being sent through the telnet is in clear text. Right now I see the network, etc, etc. If I right click on it and click on follow stream and click on stream, I can see everything in clear text. Okay, this is what I have captured using the Wireshark on my ISP router. Okay, this is where I entered my username and password. This is the password that I entered for connect to the telnet to the R2. Okay, then there this error had happened. Then I use this password for the privilege mode. Okay, so if I click here and just follow any one stream, I can clearly see everything, all the configuration of R2. So this means the traffic that I have sent through the GRE tunnel is in clear text. Okay, so let's say one more example, like on this PC I am running in the VMware. If I click on here and log in, and it will take some time. Okay, just a few minutes, a few moments, sorry. Okay, so here I'm running a TFTP server where which is used uh, con- to back up my configuration. Okay, so what I will do is use from R1 and I will copy my uh, startup configuration to the our TFTP server. Okay, that is running in the VMware. Okay, first we will check and verify if we can get to the our TFTP server. Okay, sorry, it is ipconfig and this is the IP address. Okay, this is last octet is 100. So R1, okay, ping 10.10.2.2.100, and yes, we can get there. Now what I will do is to copy startup config TFTP. Okay, press enter. What is the IP address of your TFTP server? And it is 10.2.2.100. And what file name do you want to do it? Okay, do you want to name it R1 config? Yes, I will. Okay, and my files is successfully copied there. Okay, without any issue. This is the second stick and this is the bytes it transferred. Okay, now if I go to my TFTP server, okay, and go to documents config backup, and here it is my backup configuration. Okay, this is all the configuration that I have transferred through the GRE tunnel to my TFTP server. Okay, so if I go back to my Wireshark, okay, in the capture, let me close it first and clear this, press enter. Okay, and from here if I capture the TFTP traffic, okay, let's filter out TFTP and press enter. This is the TFTP traffic that is being transferred. Okay, if I click here, still there are some data that I can see. Okay, so advisory, this is what was sent over within in the data. Okay, if I right click and click on follow stream, I can still the configuration, see the same configuration that I have seen in the telnet. Okay, so it is that the GRE traffic is in clear text. Okay, so now we will protect our traffic with the IPsec. Okay, so let's start configuring the IPsec. This is R1. Okay, we will start from here. Okay, and this is the sample configuration that I have created. And this is the phase 1 configuration, phase 2 configuration, access list that we will use to match the traffic. Okay, currently there is any, but you can use the source and destination here. and this is the interface where we will apply this policy. Okay, the first step is to create an IKE phase 1 policy. Okay, for that we will go into the global configuration mode, and here we will type in the command crypto ISA KMP and the policy. Okay, and the policy number, right, and press enter. Okay, so this is the policy is created. Okay, now we have to tell what encryption we will use. Okay, so the encryption for is we will use AES. Okay, but you can define the bits here. The more the bit, the stronger the encryption will be. Okay, and hashing. Okay, for the hashing we will use SHA. Okay, there are many flavors of SHA. Okay, here like 256, 384, and 152. The stronger the number, the stronger the hashing algorithm. Okay, so here we will use 256, and the group we will use is 14. Okay, this is Diffie-Hellman group. Okay, the higher the number, the stronger the encryption. I will use DH14, and this is 2048 bit. Okay, so press enter, and you can also configure other options here, like the key lifetime. Okay, can also be done here, right? So this is done, but one more thing we have to um, tell here, that is authentication method. Okay, the authentication method we will use the pre-share key and press enter. Okay, now let's create a pre-shared key. We have done configuration up to here. Okay, we have told the our router that for the authentication you will use a pre-share key. Okay, now we will create that pre-share key. Okay, so the pre-share, okay, crypto ISA, okay, key, and I will go with the simplicity. Okay, and the key is Cisco, and address. Okay, when I type here address, it means the IP address of the remote router WAN interface. Okay, and here I'm talking about this interface. Okay, I'm configuring this router, and I'm talking about this interface. Okay, so that is 100.64.2.2. Okay, now we have defined the pre-share. Now let's start configuring the phase 2 configuration. Okay, and for that we will use crypto IPsec transform set, and here we will give it a name. You can use any name. Okay, I will just go with the simplicity, use a TS1. After that we have to choose with for the hashing algorithms. Okay, and hashing and encryption. Okay, and we have two flavors, and that one that we start with the AH, it is stand for the authentication header, it is less secure, and other start with the ESP. Okay, so we will use the ESP. Okay, ESP and AES. Okay, AES stands for the advanced encryption standard, and it is the current standard that is used for the data encryption. And for hashing, we will use ESP, SHA, and HMAC. Okay, HMAC provide additional security. Okay, for from the data tampering. Okay, so we have normal and with the HMAC. Okay, HMAC is always better. Okay, this is Cisco method. So we will use HMAC, and after entering, my mode is changed. Okay, so here I will use the tunnel mode. There are two mode, tunnel mode and transport mode. I will use the it, tunnel mode. Okay, let's go exit. Okay, now we will create a map. Okay, so for that we will stay in the global configuration, crypto map, and you can name it any. Okay, I will use just GRE map, and the number, the sequence number, insert into the map entry, and that is 10, and it is IPsec. Okay, ISAKMP. Okay, okay. Then press enter. What is happening here? Okay, it is saying that this new crypto map will remain disabled until a peer and valid access list has been configured. Okay, so let's configure the peer. Okay, so set peer. Again, this is the R2 public or WAN interface IP address. Okay, set peer is this, and set transform set is TS1, and match address using the access list 100. Okay, we didn't create it yet, but we will create it. Okay, now exit. After that, now we will create access list. 100 means it is extended access list. Okay, and I will permit the traffic, anything that is going through my GRE tunnel. Okay, any source, any destination. Okay, you can restrict it. Okay, now our phase 1 phase 2 configuration is done. We have created it. Now we will apply it to our local WAN interface. Okay, we have to apply it to the local WAN interface, not the tunnel interface. Okay, so for that we'll go into the interface, gigabit 0 oblique 1, and crypto map, and our map is, where is our map? GRE map. Okay, we have called it GRE map. Press enter. Okay, now the configuration is done for the R1 side. Now we will do the same configuration on R2 with just a little modification. For that I will use show running configuration, and I will view the section configuration of crypto. Okay, only show me the crypto configuration. Now I will go to the R2, press enter a few times, enable, what password did I set here? Okay, right, the terminal. Okay, now we will start the configuration. We will create this. Okay, just copy and paste from here, right, exit, and copy and paste from here, but change the IP address. Okay, this is R1 WAN interface IP address. Press enter. Now let's create a transform set. Okay, same encryption we have must on both ends. Mode is tunnel, exit, and let's create a crypto map. Press enter. Okay, and copy this configuration, right, exit, go into the interface. First we have to create an access list 100, permit GRE any, enter, and interface gigabit 0 oblique 1, and copy it, press enter, right, right. Okay, now we have configuration done on both sides. So let's view our tunnel interface status. Show IP interface tunnel 1, and let's see, go for the brief, right. Okay, the currently the tunnel status is down. Have we done anything wrong here? Oh yes, the peer configuration is wrong. Okay, I just copied and pasted. This peer configuration has to be changed on R2. Okay, the terminal interface, sorry, it is our crypto map ISMP KMP and no peer. Okay, set peer 100.64.1.1, right, and press enter. Done. Let's wait for a few seconds. Okay, I can see it is still on. Okay, now that our tunnel protocol is up again. Okay, right. Okay, so our tunnel interface came up and show IP OSPF neighbors. And yes, we have full neighbor relationship and it came. Okay, so we have done our IPsec configuration and we have protected it. Okay, now let's stop the capture, close it. I will not save it and we will recapture. Okay, create a new capture, open it. Okay, now we are capturing it again. Okay, before there was a GRE, now we can see that the traffic is being encrypted with the ESP. Okay, encapsulation payload, encapsulation security payload. Okay, we cannot see what data is inside. For example, if I go back to my client here, Linux client, and let's log in. Terminal, okay, press enter. Let's exit and relog in it. Okay, username is 0hk and password is Cisco123. I think yes. Enable Cisco. Okay, before we were able to see this traffic, but let's see what we can capture now. Okay, as you can see, let's filter if there is any telnet traffic. Okay, before there was, but right now there is no telnet traffic. And let's see if we can transfer data between from copy startup configuration TFTP. Let me save it. Okay, first. Okay, copy startup configuration TFTP. Press enter. My TFTP host address and the configuration is backup R1. This is the name and my configuration is saved. Let's go back to my computer and see if it is there. It will take a few seconds. Let's see if I have captured anything with the TFTP. Okay, there is no such traffic. Okay, let's clear the filter and see all the traffic. Okay, now you can see that the data I have transferred some data using the TFTP, and also I have connected to the router using the telnet, but still there is no such traffic because all of the tunnel traffic is being protected by our IPsec, and this is the protocol that we had used for the ESP. Okay, encapsulation security. Okay, this is tunneling protocol. Though you can use see the source and destination of the public IP address, but what data is being sent you cannot see it. Okay, this is the payload, means this is the data, but everything is encrypted. You cannot see what is inside the data. Okay, so this is how we protected our GRE tunnel with the IPsec. Okay, so this is my backup configuration. I have successfully transferred my data using the TFTP, which is does not provide any encryption, but still I did not get or captured any data on the Wireshark. Okay, because it is all protected. So guys, this is how we protect our GRE tunnel with the IPsec. Thanks for watching the video. If you like it, please hit the like button and subscribe my channel. Thank you.